Binomial probability is a certain class of probability problems. And the nice thing about it is that once you determine that your particular exercise is a binomial probability question, then there's only one formula that you need to use, and it's fairly easy to compute. So let's take a look first at what are the certain qualifications that an exercise or an experiment needs in order to qualify as a binomial probability problem. So the first thing we need is that the same experiment is going to be repeated a finite number of times. For example, you toss a coin 20 times. You interview 50 people. These are examples of a finite number of experiments, and it has to be the same experiment every time. Next, the experiment has to have only two possible outcomes: success and failure. So for example, we might say tossing a coin, it's either heads or tails. Or if you're rolling a die and you want to know the probability of getting a 4, the success is you get a 4, the failure is you don't get a 4. And last, each trial has to be independent of one another. You need to know that the probability of success for every trial is exactly the same. So if I toss a coin and it's 1/2 or 50% chance I get heads, it has to be the same probability of getting heads the next time I toss the coin. Now, the next thing that we need to realize is that the probability of success, we're going to label that P. Then the probability of failure is going to be 1 minus P. And the reason for this is because we know that probability always has to add up to 1 or 100%. So if the probability of success is 25%, the probability of failure is going to be 75%. This leaves our formula. So we have the probability of R successes in N trials, meaning we're going to do an N, that's our finite number of trials, and R is the number of successes that we want in those trials, is going to be the combination of N, choose R, times the probability of success to the R power, times the probability of failure to the N minus R power. So notice again, we have written up here, P is going to be the probability of success, and 1 minus P is going to be the probability of failure. And the last thing to notice about our formula, because these exponents may seem a little bit random, they're not random. In fact, if we add them together, they will always add up to N. So if R is, let's say N is 7. If R is 4, this exponent over here, this one here, will be 3. And if N is 12 and this exponent was 5, this exponent here would have to be 7. So once we fit into these three qualifications, we can use our formula, plug everything in, and we're good.